Alright, so we're going to do 1.3. We have to define a few terms first. So, a polynomial is two or more terms in an expression. Remember, an expression is something without an equal sign. Okay? If you have an equal sign, it's an equation. The degree of a polynomial is your highest exponent. In order for a polynomial to be in standard form, the degrees, or the exponents, are in descending order. Okay, so the leading coefficient is the number in front of the highest degree term. Okay, so let's take a look at a polynomial. Let's look at 2x cubed plus 3x squared plus x plus 2. Okay, so the degree of the polynomial is your highest exponent. So that means that the degree of this polynomial is 3. Okay, and then the leading coefficient is the number that is in front of your highest degree term. So that means the leading coefficient here is 2. This polynomial is in standard form because it starts at the highest degree and then it descends, right? So here we have the third degree, second degree, first degree is what we, don't see. We don't write 1. And then what degree is this? 0. Because it's really like there's an x to the 0 here, right? We just don't write that. Anything to the 0 power is 1. Okay, now just because this is not, let's say, in standard order, if we jumbled all this up, it would still have the same degree and the same leading coefficient, right? You have to order it correctly in order to determine those things. Everyone remember these terms? Okay, good. Then let's get on to the good stuff. We're going to add and subtract polynomials first. Okay, so we'll call this example 1. 10x minus the quantity 4x minus the quantity 3x plus 8 . So keep in mind you got to do order of operations, right? So please excuse my dear Aunt Sally. We got to make sure we deal with these parentheses first. So when doing that, we got to distribute the negative inside. So we have a negative 3x and a negative 8 that way. Okay. Now these brackets are working as one big set of parentheses, correct? So you have to combine what's on the inside first before we deal with subtracting this from 10x. So let's see, 4x minus 3x is just x, and then we have this minus 8. Okay, combine your like terms, and we end up with 9x minus 8. Oh, what did I do wrong? Yeah, Hang on. Joshua.
You subtracted the x, adding in the double negative.
Right. Because see what happened here is I combined my like terms, right, to get x minus 8. But what did I lose? These brackets, right, which are like working as parentheses. So this entire quantity here is being subtracted from 10x. So I need to distribute a second time. Okay? So now when I distribute, I get this negative x plus 8, making this still 9x, but then it's plus 8. Okay? So be careful with those parentheses. I'm assuming everyone's pretty comfortable with distributing and combining like terms. We're going to move on past this. Okay? Can I turn the page? Okay, everyone okay? All right. We're going to talk about multiplying now. All right, so multiplying polynomials. All right, so let's talk about the difference of perfect squares. So this is like when you have the same first and last term, but the signs are different. Right? We've talked about this already when we were multiplying by the conjugate. When you have this situation and you distribute or you FOIL, those middle terms are going to end up canceling, right? So we end up just getting a squared minus b squared because we're going to get a positive ab and a negative ab. So these are patterns that you should be able to recognize. Okay, this helps you to cut corners when you're multiplying, is what we're talking about now. If you square a binomial, so if you have like a plus b squared, there's a pattern that follows that saves you time. Okay, and that is you'll get a squared plus 2ab plus b squared. Because that a times b term is doubled up, right? You get that twice, you combine them, and you have this positive 2ab. If you have a minus b squared, then that pattern is a squared minus 2ab plus b squared. Finally, the cube of a binomial. So if you have like a plus b cubed, this also follows a pattern. So you would get a cubed plus 3a squared b plus 3ab squared plus b cubed. Some of you might remember like Pascal's triangle. This follows that pattern, right? The binomial theorem, we'll talk about that way, way later on in the year. But this is where that pattern comes from, okay? If you have a minus b cubed, then it's similar, except some signs are going to change. So we have a cubed minus 3a squared b plus 3ab squared minus b cubed. Now, this is the one that I would say is worth memorizing, okay, because this one does save you time. See, the thing with multiplication is it's easy, right? Like we know how to distribute, we know how to FOIL, we can do those things. They're just time consuming when you have higher powers. So we have shortcuts in order to save us time. So if I was going to memorize anything, I would memorize that one, okay, which hopefully you already kind of know. Okay, so now let's try some. So we'll call this example 2, and the directions are just going to be to simplify. Okay, now when you're multiplying and it tells you to simplify, you have to make sure that you get rid of the parentheses. That's the goal, okay? So there should be no more parentheses in our answer. Okay, let's just start out kind of easy here. So negative 2x times negative 3x times 5x minus 4. Okay, so it's your choice, right? Order doesn't really matter when you're multiplying. You can do it in any order that you want. I personally would multiply the first two together because they're single terms, so it'll just create a single term. So this is going to give us 6x squared, and then we have to distribute that through to the 5x minus 4, giving us 30x cubed minus 24x squared. Now, yesterday we were talking about when should you factor out things, right? So like looking at this, we can see that there's a common factor of 6x squared, and lots of students will actually take the time to factor that back out, but then doesn't that just take you to the step before it, right? You already had that. So don't redo the problem, right? Don't go backwards. So when you're simplifying and multiplying, no parentheses left in your answer. You don't look for a common factor to take out, okay? How about x squared plus x minus 2 times x squared minus x plus 2? This problem is not a good time, okay, because there's a lot going on here, right? We have to distribute 3 times, and we want to make sure that we're very careful with our multiplication and our negatives, because this is a type of problem that, although it's easy to do, it's easy also to make a mistake on, okay? So just be organized with your work. So I'm just going to, go through and distribute this x squared first, and then that positive x, and then the negative 2. So why don't you do it, I'll do it, we'll check. Maybe check your first step with mine and see if we agree with each other. And then we're going to want to combine our like terms. So keep going with that. So you should have gotten x to the 4th minus x squared plus 4x minus 4. You doing okay? Seems easy right now, right? Seems like too easy. We're going to get there. Don't worry. It's coming. All right. So if you have x minus 4 squared, right, so here we are squaring a binomial. So we can follow the pattern. Right, you can kind of do this one in your head. If you can't, just here's another illegal thing that students do. It seems like it would just be so nice if we could square that first term, square that last term, and call it x squared plus 16, right? But if you're thinking that, you should probably take the time to write out x minus 4 times x minus 4 so you can see that middle term, okay? That's a huge mistake students make. Huge, okay? So x squared minus 8x plus 16 is what you should get there, because you have those middle terms being multiplied. It follows the pattern. You can remember the pattern if you want, or you can just FOIL it. Okay. How about x plus 2 times 3, bless you, times 3x minus root 2 times 3x plus root 2. Yes? Yeah.
When you did so when you put the negative 2 a or whatever,
Yeah.
it was like negative 2 and then x and then negative 4.
So it's not negative 4. See, when you follow the pattern, b is just b, okay? It already takes into account, by following this pattern of the minus, it already takes into account the negative, okay? Good question. Okay, this one looks harder, right? I mean, there's radicals in it, right? Like, that's kind of intimidating. But really think about what order do you want to multiply this in. So I would not start out with the first two. Okay, that's our tendency to do that, right? Because we read from left to right, so it would make sense to continue to do so in math. But what do you notice about those two? Yeah, they're the same factors, different signs in the middle. What's going to happen to the middle term? It's going to cancel. This creates a difference of perfect squares. This is way easier to multiply in the beginning because we're going to take care of that radical right away. Okay? So I'm going to ignore that first term, but I'm going to make sure that I write it down because I don't want to lose it. So now I have 9x squared. Those middle terms are going to cancel. I'm going to get a positive 3x root 2 and a negative 3x root 2. When I multiply my last terms here, I'm going to get a minus 2. Notice this just got a lot easier. Okay, the radical's gone. I no longer have 3 binomials to multiply. Okay, so now I can go into distributing just like I do normally. So 9x cubed plus 18x squared minus 2x minus 4. Okay, we have one more in this section, but I'm going to turn the page because I don't think I'll have room. Anyone need more time? Okay. Alright, so 2x minus 5 cubed. So, when I do this, I want to follow the pattern because it's going to be quicker. Okay, so I know that the pattern looks like a cubed, no, I'm sorry, yeah, a cubed plus 3a squared b, no, it's a minus, rewind, oh, where's my white out? Stuck. Okay, so remember it's a minus here because we're subtracting, and then plus 3ab squared minus b cubed. Okay, so this, now you could take the time to write out 2x minus 5 times 2x minus 5 times 2x minus 5 and then distribute, but it takes a long time. Okay, so instead let's try to follow the pattern. So the first thing you want to do is you want to identify a and b. So a is 2x and b is 5. And again, this is the same rule. Okay, you just look at the b term. You don't worry about the sign because it's already been accounted for. And now just plug it in. So I'm going to have 2x cubed minus 3 times 2x squared times 5 plus 3 times 2x times 5 squared minus 5 cubed. So everywhere I see an a, I'm plugging in 2x. Everywhere I see a b, I'm plugging in 5. And now I just have to simplify this piece. So 8x cubed. Here I'm going to get a 4x squared times negative 3. That's, what, negative 12 times 5, so negative 60. So minus 60x squared. 25 times 6 is 150. So plus 150x, and then minus 125. Much faster than multiplying those 3 binomials together. But if you can't remember the pattern, then just multiply. Okay, you know how to multiply. Everybody good on multiplying? Can we move on? Okay? Alright, next topic is going to be factoring. Okay, and we're just going to look at the patterns today. We're not going to do a ton of examples here. So, the first is difference of perfect squares. So, we've already really talked about this, but now we're just going to go backwards, right? Now we already have it in standard form. We need to factor it. So you have a squared minus b squared. Okay. So when you go to factor it, because we have 2 terms, they're perfect squares, and they're being subtracted, this is going to go right into the pattern of a plus b times a minus b. Okay, a perfect square trinomial. So let's say you had a squared plus 2ab plus b squared. So I recognize that this is a perfect square trinomial because, first of all, I have 3 terms. the first and the last are perfect squares, and then I see that pattern of that doubling of the middle term, okay, 2ab. So this factors to a plus b, really times a plus b, but we don't write our answer like that. So if you get two binomials that are the same, you need to simplify it into a plus b squared. Okay? Now, the same is true of a squared minus 2ab plus b squared. Again, a perfect square trinomial, but this time I know that the middle term is a minus b squared. So these are easy to recognize usually, right? You can also use guess and check here if you needed to. The two that you have to really memorize, that you can't really back into, is the sum of cubes and the difference of cubes. So a cubed plus b cubed. This factors to a plus b times a squared minus ab plus b squared. Then you have the difference of cubes. So if you had a cubed minus b cubed, this factors to a minus b times a squared plus ab plus b squared. I would highlight this because you need to memorize these, okay? One more thing. Grouping. So in order to factor by grouping, you need 4 terms. Right? You group the terms into 2 pairs. And then you factor out a GCF. Let's just look at an example of this. So let's say we have x cubed minus x squared plus 4x minus 4. Here, you don't necessarily know if it's in order. It could be out of order, you know, so you might have to kind of reorder things. In this case, we're just going to try. So remember, we're looking for a GCF within these 2 terms. So between x cubed and x squared, we should factor out an x squared, right? So when we do that, we're left with x minus 1. Now the goal is to then group these 2 terms together, factor out a GCF that will give us x minus 1 left over. So what is that GCF? 4. So I'm going to factor out a positive 4, leaving me with an x minus 1. At that point, I have this x minus 1 in common, right? That's my GCF, that comes out. So I have x minus 1 times x squared plus 4 left over. The other thing you want to do is you want to look at this and make sure that you can't go further with it. Now this, although you have perfect squares as the first and the last term, it's not a difference. It's not a subtraction, right? So you can't factor this any further, okay? So this is fully factored. Every time you're factoring, you want to look through every single set of parentheses and make sure there's no common factor left, okay? So if this was like 2x squared plus 8, you want to make sure you take out the 2, okay? That's fully factored. How many people factor using guess and check? The guess and check method, where it's like, okay, what multiplies to this adds to this. Okay? How many people use the box? Maybe use the box. Okay. All right, just curious.